Now, before we start, let me give you some maybe a little bit of what we are doing in the next few hours. So I hope we can finish we still have chapter 3 today, inverse trigonometric, and I'm trying to start a new sections, the related rates. Okay, and yeah, I hope we can finish today and maybe review it one more time next Thursday. So because I have my vaccination schedule today, so maybe we will finishing our course maybe around 2:45 or 2:50. So 2:50 finish, and then um, I have prepared the feedback time, and then yeah, finish the lecture. Okay, and because of we are going to finish chapter 3 very soon, we will have another quiz, but I'm not sure when. Maybe next week, maybe next 2 weeks. But our midterm, let me write here first. Our midterm, our school or NTUSD, our university, they prepared 10 to 16 November, right? But our course, we will not following this schedule. We will have probably around 21st, I think 21st. Oh, 22, sorry. 22 to 26 November. Probably this week we will have a midterm. Okay, probably. It can be Tuesday or Thursday. Maybe Thursday, maybe. Or maybe Tuesday. So probably this will be our midterm, and the midterm will be arranged from chapter 1, 2, 3, and 4. So I will finish hopefully this week chapter 3, and then we'll have some exercise, and then we start chapter 4 next week, and maybe we finish chapter 4 around middle of November, and we are going to have the midterm. So the quiz, we will have quiz 2, maybe around maybe first or second week of November. So it can be next week or next 2 weeks. So just be prepared. Whenever we finish the chapter 3, and you know that it will be a time for quiz. Okay, and please check your at least Moodle, and then if you know that there was a quiz announcement, you need to go to the Google Classroom. I will post the announcement maybe on both platforms, but the details in Google Classroom. So you need to check the details, more details on Google Classroom. So check periodically. I don't want you to be missing out the quiz. I think a few students miss out the quiz, and also some students, they are not using their real names. Don't know why. I don't know if it is from this class or the other class, because I have 2 classes of calculus. I give the same quiz questions. Not sure who the students are. I think there are 2 students not using their real name. They are not including their student ID. I believe you are not respecting me as a teacher. You are not respecting the class also. So please write with your real name. If you are doing this again, I will straightforward 0. Okay. And if you are not really not let me know, if you don't let me know who you are from the quiz one that didn't use your real name, then I will not give you any score. Okay, even though your score are quite good, quite good. Okay, let's start the course. Let me start with the questions on the feedback time. Okay, so feedback time, asking the tangent line to the curve, right? We need to find the equation of tangent line. The curve, we have, this is our curve. So this is the curve. The point is 0, 0, I believe, right? At 0, 0. So first, whenever you see any tangent line, what you need to do is finding the slope. How to find the slope? You find the first derivative. Okay, to find the first derivative from this equation here, okay, first doing this is d dx, those to differentiate the whole equation, and we are doing implicit differentiation. Okay, so implicit differentiation, so you're doing the product rule here. The first one, the left one here is product rule. Y prime e with the power of sine x, y, and then differentiate, become cos sine x, e with the power of sine x, and then equal second product rule here, x cos y, differentiate, cos y minus xy prime sine y. Okay. If you're still struggling to differentiate this, you need to do a lot of work, at least until you get to the point where, okay, I can do it, and you can differentiate it in a quick way. Okay, that will be better. If you still have some trouble here, struggling to solve, you can check with your TA, and hopefully your TA can prepare some homework for you, and maybe some suggestion for you how to study or how to work this implicit better. Okay, and we need to move forward from now. So we solve this. Okay, so after we differentiate, we are going to group each part and solve the y prime. So y prime, or dy over dx, will be equal with this whole equations, and then plug in x and y 0. So plug in 0, 0, let's write that, and then you will get that this is actually just 1. Okay, and then you know that the point that passed through is 0, 0. So basically you are going to have y equal x. Okay, and I think majority you get correct answer. Okay. Okay, true or false. Okay, remember, ln is basically log with base e. So e is a number, this number, right? So log with base e 10 is actually a constant. This is a number, so this should not be okay with this. So it should be false. So I don't know why still a lot of students choose true. Okay, next questions. Questions is having the functions. You have the c here that you need to find. For one value of c is f prime of pi over 4 is equal to 6. Okay, now f prime if you are going to differentiate, it will be equal. So cx becomes c plus 1 over cosine x, and then need to multiply with the chain rule. So cos x becomes negative sine x, and it will be c minus sine over cos. And we need to put in pi over 4. Sine pi over 4, cos pi over 4 is tangent pi over 4, which is 1. So c will be 7. Okay. Yeah, a lot of you got the correct answer, but still you have 5 in your answer, so need to be careful on that. The table seems wrong, but it's true that this is the highest. So I want to know who is the magical rhino. Can you write your student ID? Okay. All right. So yeah, I will keep on my eyes on the trophy. Okay, who are collecting the trophies. So at least if you collect maybe 2 or 3, you can prepare. You can prepare yourself to receive my gift. Okay. Hopefully, when we have the physical exam, that you are going to class. So I will give that the gift, or maybe on the final exam that I think all of you already got in Taiwan, because I think in midterm the overseas still, most of you still outside of Taiwan. So I think maybe on final exam on January, you guys already here. I can prepare to give, and I will give to each of the winner. Okay, we can continue. So the ln, I will say that is already finished. We discuss, and maybe if we are going to discuss another logarithmic, or maybe another about the chain rule, implicit differentiation, maybe if we have time, we can review and maybe try to work on some exercise. Okay, I believe I already post some assignment for you. That assignments is prepared that you can actually try to practice and familiarize with the derivatives. Okay, so like I said before, if you have the tools, especially the ln and the implicit, that is very powerful tool for most of all the complicated cases in derivatives. You will be fine if you are already mastering the ln and the implicit. Okay, so we will go for this derivative of inverse trigonometric function. Let me put here, and don't worry about the about all of this here. Let me start with the, if I have, start with sine x. Okay, if I have sine x, probably this is the way you are looking at. Maybe I will write this is 0. Maybe pi over 2 here, and then maybe pi here. And then yeah, let's just start. And maybe this is, I can write this is negative pi over 2. Okay. If we are going to look at the functions of the trigonometric, the basic trigonometric functions like sine x. And if we are going to check, okay, checking the horizontal test to check whether this is horizontal line test, okay, horizontal line test. Do you remember why we need to use the horizontal line test? This is to check whether the functions, maybe to check functions is 1 to 1. Okay. If something happens in this sine x, you have crossing these 2 point here, meaning function sine x is not 1 to 1. Right? So to make it 1 to 1 functions, what we need to do is we need to restrict the domain. So that f of x is 1 to 1 function. Okay. So let's restrict the domain. The default, if you want to restrict the domain, you start from the nearby the 0. You look at the functions here. I think if you just start from this, or let me make a red line or pink line here. If we start from here to here, the pink line, I think if we check the horizontal line with the horizontal line, we are precisely just crossing only one point, right? Here, here. It's just 1 point, right? So if we are restricted the domain on that point from minus pi over 2 until pi over 2, we have 1 to 1 functions. If we have 1 to 1 functions, we have the inverse, okay? So the inverse, we have f of x sine inverse x. We will have sine inverse, in which what you can do is first you can have the so you have, let me write here. So this is the sine, this is sine x, okay? Remember, if you have the inverse, if you have a graph, you can reflect to the y equal x. So this will be your inverse, more or less, okay? My drawing is not really that smooth, but at least you get the idea that you have the inverse. If this is f of x, the yellow one will be the not, sorry, it should be inverse, not f prime, f inverse. Okay. Okay, what does it mean, the inverse? Inverse means domain become range, and range becomes domain, right? Or if you look at this, we have if this is y equals sine of inverse x, then x is sine y. Okay. Okay, if we look at this, x equals sine y, because we already learned implicit differentiations. Okay, we already learned, right? Then we can differentiate left and right at the same time. This will be 1 equal cos y and then dy over dx. And then you will get the expression for dy dx. Dy over dx is 1 over cosine y. Now we still have this y here. So we need to make it into variable x for this case, right? What we can do is, usually what I'm usually doing, because I know that I have restricted from minus pi over 2 to pi over 2, then I know that at least the angle should be an acute angle, okay? An acute angle, at least, okay? So I'm usually, let me write down here. And so usually I draw the triangle like this, back triangle. I draw a triangle. Remember that we have the x equal sine y. So y is our angle. So let's put y as an angle there. And then sine y will be, this is x over 1, right? If you remember the sign. So this will be x. This will be 1, right? The other part will be square root of 1 minus x squared. Okay? And then, if we have cos y, this will be square root of 1 minus x squared. That's why our dy dx becomes 1 over square root of 1 minus x squared. Or if we write completely, we can write as d dx sine inverse x is equal with this. Okay. Okay, let me give you some time to check my notes and maybe to think whether you have some question or not. Okay. I think, okay. Maybe, okay, this big, I think it's, okay, if you have any questions, you can write on the chat box. Maybe you feel some of the part at the introduction is a little bit too fast, and maybe you need to ask the concept that you are not really sure. Okay, I think we can move on. Let's see. Okay, let's check with the other inverse of trigonometric. Okay, so we have done sine inverse. Now, if we have tangent inverse. Okay, same thing. What we have done in the sine inverse, we can let this become y equal tangent inverse, and then this x is actually our tangent y. And then we can draw our triangle and then name all the necessary terms. Angle y, now it's x, this is 1. Where's 1 come from? This is x over 1, right? It's the same thing. So, and this is wrong, right? It should be here, sorry. So this will be x squared plus 1 square root. Okay, the hypotenuse. And then we can start to do the implicit. It will be 1. And then tangent, what's the first derivative of tangent is secant squared y and then dy dx. Again, if you don't know how to find the first derivative of the tangent, you can refer to sine x over cos x and then differentiate. This will be equal to cosine squared x, and then this will be cos squared x and then plus sine squared x, right? Using quotient rule, and you will get that this is 1 over cos squared, which is the secant squared. Okay, and then you have this, then you can have dy over dx is 1 over secant squared y, or this is cos squared y. So from here, we know that our tangent y is x. We can have also cos y. It is 1 over this, and then cos squared become 1 over x squared plus 1. Then that is precisely our answer. So d dx of tangent inverse x is equal 1 over x squared plus 1. Okay. So with inverse trigonometric, the derivatives becomes more variable, more vary, right? So if we look at, maybe let me give you just a few minutes to look at this first, okay? And then we can go back to look the whole inverse trigonometric things that probably you need to check. Okay, let's go back a little bit. Looking at this table here, we are going to see that you have the sine inverse, cosine inverse, and tangent inverse. Okay, I believe this 3 on the left is the principle in the inverse of trigonometry, or I believe if you are just make sure that you know one of them, and I suggest to you, you need to remember this tangent inverse because the result here is quite simple. It's not including any square root, right? And you will know why it's quite important when we are going into the integration part. Okay. Other terms, especially this cosecant, secant, and cotangent, is not too important because basically cosecant is 1 over sine, and secant is 1 over cosine, and cotangent is 1 over tangent. And you can find this eventually when you are doing some calculations that you'll find, and you can derive it by yourself, I think. Okay. And because I haven't checked this cosine inverse, you can do it by your own. Try to show the, or try to derive the formula by yourself. Okay. Because it helps you to remember, it helps you to get to the inverse trigonometric functions. Okay. And the idea, like maybe a typical questions, I think it will be the same as what we have done previously in the derivatives, but now you are getting a lot of informations now. You have the inverse. Maybe the first one is just power rule with some general polynomial. You have the product rule for the technique. You have the quotient rule. What else? The chain rule, implicit. Oh, the trigonometric first, and then the logarithmic. Oh, sorry, exponential first. Exponent, log, inverse trigonometric. So all of this are basically the tools that you are having, and you can use all these tools according to your preference. Okay, because some questions you can solve the questions by at least 2 or 3 methods. You can directly derive, or maybe you want to change the formula first, and then you can derive at the end. That's actually up to you. So by doing this, by holding these informations, you can have a strategy, right? You can have a strategy. You can have a strategy which rules you are going to use. Okay, and the more you are having an efficient and correct and logic, that is actually how your mind is trained to think in mathematics in an efficient way. Okay. Like in comparison, maybe you have a computer or laptop or maybe smartphone. The more they have, the more optimized they are, I believe their work will be done quickly, and it will not exhausted the battery, right? The more you have, it will be not wasting the energy, right? Not wasting the battery, and that will be the better product, right? Okay. And that it's a similar logic in mathematics, okay? In calculus. An example in the inverse of trigonometry, because we are still in inverse, maybe you will have like cos and then sine inverse like this, x, and then you need to find this, or maybe ddx sine and then cos inverse x, and then what it is. It can have any combinations with chain rule. Maybe you can solve it with implicit, and so on and so forth. Okay. So all the things, including the derivative and its rules, I think mostly we have done it. Now, the next section, okay, we will going to skip. So in your textbook, there are still 3.7, 3.8. We will not going to involve that because I think this is more in line with physics and other science part that are using calculus to evaluate or to calculate. But we are going to just focus on calculus now in our courses. So I will skip this, and I think we are not really having much time left for this 3.7 and 3.8. So we will directly go to 3.9, okay, which is the related rates, okay. And let me tell you why this is so uh, not difficult, but maybe a little bit complicated. Okay, a little bit complicated, but actually it's quite simple if you know how. Okay, to understand what related means, just read the question here, the example one. Air is being pumped into a spherical balloon, and the volume increase at a rate of 100 centimeter cubic per second. How vast is the radius of the balloon increasing when the diameter is 50 centimeters? So let me give this to you to solve for a few minutes. Maybe just think first whether you understand the question or not. So first, let's see the important words here, the important point. First is there are volume that increases. Volume increases, so you have a rate of change. So of course, this is about the calculus, about rate of change. So you have volume increase. That is the one that you know. So we are going to write dv over dt. So we name the word volume over time becomes dv over dt. Okay. The questions are, how fast is the radius of the balloon increasing? So we need to find the change in radius. So when you have the change in volume, you have also change in radius. So dr over dt is the question, right? Or to be precise, the question is asked dr over dt when the diameter is 50 centimeters or the radius is 25. Okay. So first, you get the information first, and you get the goal, what you need to find. Okay. So given, so this is the given information. This is the unknown that you are going to find, right? And then from dv over dt and dr, what can we relate? What can we connect? Of course, because this is talking about spherical balloon, this is in our discussion, spherical balloon. Then we have volume of balloon, which is the spherical. We can just write the balloon or the sphere is pi r cubed. And volume equal 4 over 3 pi r cubed. And And the important thing in related rates also is try to be simplified, or try to be as simple as you can. Do not assume anything like making your life difficult. Don't do that. Like the sphere, you are not questioning is the sphere really sphere, or maybe having a defect, or maybe an oval, or maybe anything. Just follow the question. When the question is saying it's sphere, assume it's a perfect sphere that you can just use pi 4/3 pi r cubed. Okay, then to make dv/dt, you can differentiate all of this with d dt. You introduce another variable because this is related to times, so I will introduce d with as time. So we will have dv/dt equal 4 pi r squared. Don't forget dr/dt because of the implicit rules. Okay, and then we have dr/dt and the question is asking when r is equal to 25 or diameter is 50 centimeter. So this will be 4 pi and then 25 and then 100. So this will be 1/25 pi centimeter per second. This will be our dr/dt that we are looking for. Okay. Okay, so most students, they feel that this related rate is difficult because you will have like these words here. If you don't know what it is, maybe also you are not really familiar with English words, then you may have difficulty. But I will try to make the words as simple as it is and maybe provide some picture to you that may be helpful. But before that, let's just try and practice with the question on the book first, with the question on the textbook. Okay. Okay, now look at the example 2. Okay. Read first and then try to understand. This is the question that I think I already mentioned when we are dealing with the implicit differentiation. I give this as example, although different in numbers. I mentioned a ladder, maybe 5, right? A 5 meter I mentioned, and then we have 3, 4, 5 triangle, Pythagorean, right? But this is actually similar problem, but different, a little bit different question, but similar way to solve. So maybe you can read first and then try to understand first the question. Okay, now if you look at the triangle, so you have a ladder. So this is a ladder, or maybe I will write the ladder marking with right line like that. This is the ladder. This is 10 feet. Just write 10. This is the wall. This is the ground. If you get this question here, what can you do is understand the questions, write or draw a diagram, and then naming the terms. Let's say the wall, we name the wall as y and the ground as x. It's easy, right? Y-axis and x-axis. And then it say that the bottom of ladder slides away from the wall. Slide away from the wall at a rate of 4 feet per second. So the bottom ladder, okay? The ladder, this is the ladder. The bottom is here, right? It slides away, so it's going there. It slides away at rate of 4 feet per second. So dx over dt is 4. It's a little bit different from what we have done, right? But similar way to solve. How fast is the top of the ladder sliding down the wall? So the question will be this, dy over dt. That's the question. When the bottom of the ladder is 6 feet from the wall. So when it's 6 feet, so you have 6, and you have 10, and you have 8, right? Well, it's not proportional. Let me change that. Well, it should be like that. So when x is 6, then y is 8, right? So we have that information. Okay, again, we can connect this using Pythagorean theorem. We have that, and then we are going to differentiate this with respect to t using the chain rule and so on and so forth. We are going to have 2x dx dt plus 2y dy dt equals 0. And dy over dt is equal, solving this is negative x over y dx dt. And then substitute, this will be 6, 8, and 4, negative 3 feet per second. So this is our dy over dt. So negative here because I'm putting positive in the dx. So negative here means the y here reduce, right? Reduce. So dx dt going down negative 3 feet per second. Or maybe I think it's better decrease, right? Decrease, yeah. Like in the function decreasing, not reduce. Okay, that's the example 2. Okay. Any questions first? Any questions? Okay. The idea for the related rates is actually this way. Okay. Let me just explain. So first, read the problem carefully. Uh, Later on, when you are having trouble with your maybe textbook, when you read the questions, maybe you are not familiar with the English terms, um, you can look in the dictionary, or maybe you can ask me if you want, if you are really stuck what the problem means, and then draw a diagram if possible. So draw a diagram like we done before, and then introduce notations. So name all the symbols that can be quantified. Okay, and express the given informations and the required rate in terms of derivatives. This means dy over dt or dx over dt, right? And then write an equation that relates all the problem that can be quantified. Okay, and then use the chain rule to differentiate both sides with respect to t, and then substitute the given information, and then solve the unknown. Okay, that's all. This how to solve the problem. Okay, let's see another problem. Let's see the example 3. Okay, this is the example. Let me give you some time to think, to read, and maybe you can try to solve. I'm giving you maybe 2 minutes, 2 minutes, yeah, 2 minutes to solve. Okay, so you have a water tank, or maybe let me help you for the drawing. Okay, a water tank has the shape of an inverted circular cone. So this is a cone but inverted. So we are having a cone like an ice cream cone, right? Like an ice cream cone. Okay, imagine that is our cone. This is our water tank. Okay, and then we have a water inside. Maybe that is our water. So this is the water, and then we have the radius. The base radius here is 2 meter, and the height here, so the height here 4 meter. So 2 meter, 4 meter, and then you have water is being pumped into the tank at a rate of 2 meter cubic per minute. So which means this is dv over dt. Find the rate at which the water level is rising when the water is 3 meter deep. So this is 3. Asking when this is 3 meters. Yeah, you can try to solve. Okay, so probably in the related rates, you need to keep in mind that there will be several formula that you need to know beforehand, like a geometric, like a volume, area, Pythagorean, something like that, that can help you to solve this. And of course, if you see here, this is a volume of cone. If you remember, volume of cone is 1/3 pi r squared, and then height, right? And then how to solve this? So the question is asking, find the rate at which the water level is rising. So the level. So there will be something level there that is need to be found. If we are going to name this h, then the question here is actually asking about dh over dt. Okay. If we look at this cone first, if you look here, then you will notice that when the water level is rising, when h is rising, there is another radius that is in here, let's say r also rising, right? And precisely with the triangle property, if this is 2, this is 4, this is h, this is r, okay, we have this relation for the triangle property. Okay, so I want that all the terms variable here all becomes h. Why? Because we want to find the level, rate of level, okay, rate of change of level. If the question is asking the radius of the water, then we are going to change all into r. Okay, now because we need to change to h over 2, we need to change all the r with h over 2. Or maybe I will directly write this is 12. And now differentiate with respect to t. We will have dv over dt, and this will be this. And the question is asking when the water is 3 meters deep. So dv over dt is 2. This is 3. This is dh over dt. So dh over dt will be equal with 8 over 9 pi. Meter per minute. Okay. Okay, any questions? Okay, another typical question. I think I will finish today. I'll give you 2 more examples. Yeah, wait. I will just put something here first. Don't worry. I will be back to previous slide. Wait. Just putting the example, because if not, then I will be confused on how I can. Right, okay. 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 Any question from here? This one, the example 3. Uh, this is basically from example 1, example 2, and example 3. All these are typical questions, like a ladder, the volume that change, and then you have some tank with water inside, and the water is changing the volume. It is a typical question that uh, have it might happen in at least in your textbook. Okay. Okay. I hope finish this example 3. Uh, I already put the example 4 and 5. Let's check it out together. Okay. Let's check the example 4 first. This is also a typical question. A car a car A traveling west 50 mile per hour. This means mile per hour. And car B traveling north at 60. And both will be headed for an intersection of two roads. And then at what rate are the cars approaching each other when car A is 0.3 mile and car B is 0.4 mile from the intersection? So you will have two cars that are going to have a meeting point at an intersection, right? And then uh, you need to know the rate when the car is approaching each other. So maybe this is A, maybe this is the car. Oh, okay, this is the car. Okay, car A going to the left. Okay, and then maybe the other one will be here, car B. There will be the car B. Okay, and then it will be also going to the intersections there. Okay, let's say we are going to have some meeting point here. Let's say this is C. Okay, so this is A, B, C. Okay, And let's just name all the things. Maybe this is y because it's going to the north, to the y-axis, along with in line with the y-axis, and then this will be x-axis. Actually, you can name with any variables you want. And how to connect A and B? There is something to there will be some formula to connect these two, and I think the basic one is just connecting that B and A. When you are moving B and you are moving A, and imagine that they will arrive at C, then there will be a relative distance between A and B. Let's just draw that this is a relative distance, and we say that maybe this is Z to make it easy to remember. So X, Y, and Z. So and as X and Y, or as A and B getting closer to C, then we are going to see that Z will be also getting shorter, right? Let's say when A is here, B is here, this is C, right? This is C. But it's getting shorter and shorter, and we can use that information as our formula to relate all the informations here. Okay, so we are going to include the Pythagorean formula, differentiate with respect to t. Let me write z in the left, so 2z dz dt equal to x dx dt plus 2y dy over dt. We are going to remove all 2 from the equations, and we are going to get dz over dt will be 1 over z plus y dy over dt bracket. Okay, when x is 0.3, y is 0.4 according to the informations, z with Pythagorean will be 0.5, right? And dx over dt is 50, but because it's making the x is decreasing, I will give negative. Dy over dt, because it's also making this decreasing, I will give negative also. So we can impute all these equations. And this will be, if you calculate, will be around 78 miles per hour. So this is the questions that so this question is, at what rate are the cars approaching each other? Okay, this means that when A is going to the west, and B going to the north, meeting at C, maybe at closer at C, maybe here, like I mentioned before. This is the one that we are looking for. How fast Z is decreasing. So how fast these two cars are approaching each other. Okay, this will be the answer. So the car, you can write car approaching, or the cars approaching, or both cars approaching each other when, let's say, x is 0.3, y is 0.4, is negative 78 mile per hour. And need to remember that negative signs here is depends on you. Okay, we can write this as positive, and this will be positive. But that means you need to write and explain what positive in your case means. Both are correct as long as you are consistent, okay, in your writing and your logical reasoning. If you are consistent, there will be no problem with the negative and positive sign. Okay, you can write the cars approaching each other at rate of 78 miles per hour. This is also correct. We don't really need to know the positive and negative as long as it is in line with the conclusion. Okay, I hope you don't get confused on the negative, positive, negative, positive. Okay. Okay, let me move here, and then let me give you some time to think. Okay, if you have any question, you can write in the chat box. So I think related rates depends on how we are going to look the problem. Okay, and I think you can have more tutorials with your TA on solving some problems in related rates. Maybe next week, because I think this week will be mostly reviewing your differentiations, implicit chain rule, in logarithmic. Mostly that will be your TA session for today, mostly. But I'm not sure if your TA prepare anything else. Okay, if you guys finish, let's just move a little bit here and read the question first. This is about a man walks along a straight path and it has a lamp or spotlight. So spotlight is a lamp, okay? A lamp that is usually for like in performance, you have light that is spot on the performer. That is called the spotlight. Okay, so it is a lamp. The spotlight is located on the ground 20 feet from the path and focused on the man. At what rate of the spotlight rotating when the man is 15 feet from the point on the path closest to the light? Okay, so I hope you don't get confused on the problem. I think we will have maybe 1 or 2 example for Thursday, and then move to the next chapter. And I hope this week finish chapter 3, and maybe next week we are going to have maybe review a little bit of chapter 3 and then move to chapter 4. Okay, and as I mentioned, maybe in the third week or maybe the fourth week of November, maybe that will be our midterm. That will be our midterm, and before the midterm, we will have another quiz. Please be prepared. Okay, please be prepared. Check your Google Classroom periodically. I already mentioned all the time, but a few students, they're missing out the quiz. Okay. Okay, let's start to work on the example 5. Okay, let's draw the illustration. So maybe a man is walking. Man is walking, maybe alongside here. So a man walks, and then imagine this is the ground. Okay, the ground, and you have the spotlight maybe here, and it will be shine on the man. Okay. And then this will be so this is the path that the man is walking. So from the path until the spotlight, there will be a distance 20 feet. And let's say we name our ground, our path is X. Okay, so the man is start walking from here. Okay, from here. Okay, so the man is here until here, until this one. That one is X. So notice that the questions is asking the rate at which the spotlight is rotating, right? So the spotlight is rotating. So maybe the first spotlight is when the man is still here, right? And then it's moved here, and it's rotating, right? It's rotating. So it's moving. So the spotlight, if you see from the top, it's moved from here and going to move another way there. So it has some, let's say the change here is some theta here. There's some rotations. So if we are going to take the diagram in more simple, we have X, we have 20, and we have a theta here. Okay. We are given that the speed of the man's speed, he walks at dx over dt is 4 feet per second. We need to find the rotations, right? The angle, the rate of change of the theta. Okay. When x is 15. That's the questions basically. So how do we deal with this? How do we connect the x, theta, and 20? We can start from trigonometric. Okay, this is also can be done. So trigonometric, if you see 20 and x, this is a tangent theta. And you know that from here, we can say that x is 20 tangent theta. And from this tangent here, we can differentiate with respect to t. This will be or maybe directly from here. Directly from x 20 tangent theta and differentiate. So 1 and then dx over dt. And then 20 tangent becomes secant squared theta and d theta over t. And d theta over dt will be 1 over 20 cos squared theta dx over dt. Okay, when x is 15, okay, let's say when x is 15, this is 20. What is theta? So we can directly have from here cos theta is what? This is 15, 20, 25, right? Yes, this is 6 to 5. Yeah, 25, right? Right. So cos theta will be 20, 25, or 4 over 5. That we can use to solve this. This will be 1 over 5. And then dx dt is 4. This is 4. And then cos squared theta will be 4 over 5 squared. Or this is 16. Oh, wait. It should be 1 over 5. Because this is 4, 5. Okay. And then 16, 125. And so the rate of spotlight rotation is 16 over 125 radian per second. Okay, I think I will finish until here. Okay, finish until here. Okay. Any questions? So rate of change, it can be about geometric, area, volume, Pythagorean. It can be about the theta, the angle that can be changed. Okay, it can be volume, area. And the questions will be vary. There will be a lot of topics that include, but most of all the problems in related rates, what you need to find is you need to read carefully, draw a diagram if you can, name all the quantified things, and find out what is your goal. Okay, and then find the formula that can connect all the things, and then differentiate with respect to t, and then find the symbols that you are looking for. Okay, if there's no questions, okay, are you finished this? Let me give you 1 more minute, and then we can go to the feedback time. All right, we are going to move to our feedback time. Okay, actually, I prepared just for the inverse trigonometric, so I hope that's okay. Maybe feedback for related grades. Maybe I will keep on next Thursday. Okay, next Thursday. Okay, please join the feedback time. Okay. Okay, let's start. Okay, 26 students. I think we have more students, right? Well, let's just start. 3, 2, 1. Let's start. Yeah, you have a lot of times. I believe you are writing the notes. You can get correctly. Okay, 5 of you still write through. I'm not sure how. Okay, okay, let's move on. Okay. Okay. Let's continue the questions. 3, 2, 1. Let's start. Okay, I think that's enough time. 3, 2, 1. Okay, thumbs up. All right. Okay. Okay. Some of you get the correct answer. Okay, let's continue. Okay. Okay, let's go. Last question. 3, 2, 1. Okay, choose A, B, C, or D. Okay. 55, 54. Okay. Half minutes. Okay. 12, 11. Okay, 10 seconds. 5, 4, 3, 2, 1. Oh, only 5 students got correct. Okay, I will maybe review it on Thursday. Okay. Oh, great, great. Congratulations, Young. Congratulations. Okay. Okay. Okay, let's collect all the trophy. Okay. Wait for my gift. Okay. I promise you. Okay. So that's all for today. Thank you for joining. Okay. I hope you get benefits from today's class, and we will review some of the part on next Thursday. Okay. So thank you. And you can leave the meeting. You can leave the Google Meet. Yeah, you're welcome. You're welcome. Oh, QR code. Okay, wait, wait. Okay, here. Attendance. Okay, if you need attendance. Okay. Okay, if you finish, you can leave the Google Meet.